Okay, hello everyone. Welcome to today's session. Today we'll be talking about, one of the interesting aspect of physical chemistry in particular. So, in physical chemistry there are quite a few units, but one of the three important units within physical chemistry, I like to call them the three pillars of physical chemistry. And I'll tell you why I call these the three pillars. These topics are mainly thermodynamics. We've heard about thermodynamics everywhere. Um, so I'm going to call this chemical thermodynamics. The second one is chemical kinetics or kinetics, whatever you want to call it. And the third one is chemical equilibrium. These are actually three different units within physical chemistry, but I like to sort of, carry them together because there is a lot of there's a big reason why these are, sort of put together in physical chemistry, why they are right next to each other. Um, all of these units are actually trying to tell us something about the nature of chemical reaction, the mechanistic side of chemical reaction, but in different way, right? So let's say you have a reaction A goes to B, right? Let's say there is a reaction, right? Now, if we are dealing with the energetic aspect of this reaction, let's say, how much energy is incoming or how much energy is outgoing, whether this is a exothermic reaction, endothermic reaction, and even more important than that, whether or not this chemical reaction actually happens spontaneously. You know, there are a lot of reactions in nature which are very spontaneous, like for example, if expose a piece of sodium metal into the environment, it's going to react with the moisture and cause that a spontaneous reaction, right? That's a very fast reaction. There are some reactions that take a day or two. For example, rusting of iron, which is a relatively moderate speed kind of reaction. There are also reactions which are extremely slow that take years and years to complete. And not all when not all things when mixed together do react. There are also processes which do not happen. For example, there are so many molecules in the environment, air molecules for example. They're constantly in contact with your physical body, with your skin, with your hair, with your fabrics. Those molecules are not reacting. They are in contact but they are not reacting. So what determines whether a reaction happens? The spontaneity of the reaction from an energetic point of view. All of those are covered in chemical thermodynamics. Okay, I'm not going to go into the detail, but just going to tell you the chemical thermodynamics tells us about the spontaneity, the reason behind the spontaneity of a chemical process. The other one is chemical kinetics. Chemical kinetics. You can guess by the name itself, kinetics meaning speed. So let's say this reaction happens. How fast does it happen? You know, what determines the speed of a reaction? Can we tweak some aspect within the reaction so as to improve the speed of the reaction? Can we make the reaction faster? All the parameters that are going to impact the speed of the reaction. We are gonna discuss that in chemical kinetics, right? There's also the quantitative side within this chapter where we calculate the rate order, right? All that aspect. Even in chemical thermodynamics, there's a quantitative side where we calculate the enthalpy change, the energy change that's happening in a chemical reaction, the activation energy calculations, right? So chemical kinetics again deals with the speed of reaction and the factors and the tweaking of the chemical reaction to improve the speed. And finally, chemical equilibrium. This deals with a very, unique kind of reaction. In nature, not all chemical reactions are one directional. There are also reversible chemical reactions. So chemical equilibrium deals with reversible chemical reaction. And whether a chemical reaction is one directional or reversible, that's not under our control. Something to keep in mind. That's completely dependent on the nature of the reactants and products, the kinds of bonds that are breaking and kinds of bonds that are forming. We'll go into the details of that that aspect in the chapter itself. But chemical equilibrium deals with, reversible reaction, and most importantly, it answers the question to what extent. Okay, this is the answer that we are trying to find in chemical equilibrium. In chemical kinetics, how fast we're trying to, you know, delve into the speed of the reaction. In chemical thermodynamics, uh, first, does it happen? That is one important question that we're asking. Will the reaction happen? Right? And we are, of course, delving into the energetics aspect. Okay. So these are some of the important questions that we're asking in these three important topics in physical chemistry. Does the process happen? If it happens, how fast does it happen? And if it's a reversible nature of process, to what extent does the reactant convert to B? You know, in some cases there could be, 40% A and 60% B in an equilibrium process when the reaction has reached the state of equilibrium. In some reaction, it could be 80 reactant, 20 product. In some cases, it could be 10 reactant and 90 product. Again, our goal is to get more and more of B because we are always interested in the product, right? So in this chapter, we are also going to deal with different factors, or how we can, move the reaction more towards the product, how we can optimize the yield, chemical yield of the reaction. You know, there's a principle called Le Chatelier principle, and within that principle, we are going to talk about how to move the equilibrium to the right or to the left. But mostly we are interested in finding, in making more and more of B. That is the chemical yields, right? Making more product. So these three topics, thermodynamics, kinetics, and equilibrium, go hand in hand. Um, and when you encounter this chapter in physical chemistry, please try to connect the dots. That's gonna make the story more interesting, more meaningful, and hopefully that's gonna help you retain information and understand the chapter better. Thank you very much. I'll see you very soon.